Where did we stop in the last class? This is the next lecture. Second of both or third, I think. Have you done with any evaluations already? Did we do this numerical?
Yeah.
No, sir. No, we work on it. Given any homework? Right, this question 3.
Yes, sir.
Have you tried already?
Yeah.
Everybody has tried question 3?
We did it.
You did it. Did we do this or we did this?
We did that.
You did this as well as the third one. Then try 6 1 6. Did we do this? What question number it is in your book? 6 only? Okay, let's try 6. Everybody, we are doing question 6 online student. What is given?
Sir, 4 times.
Given 3 points where the force is applied. Here, point A, and point B, where the force is applied. At A, it is applied in this direction. B, it is applied in this direction. What is the magnitude of force? You will have at A equal to N. Okay. F and B is also what we have to find is this is point O. What is the distance of separation between the two points? 50 centimeters. 0.5. And O is the midpoint.
Yes.
So how much will this be?
Sir, 2.25.
Sir, can you speak a bit louder? I can't hear your voice.
O is 0.25 meter from the perpendicular distance from FA. Okay. Likewise, this point O is 0.25 meter away from the line of action of force P. So we always take the perpendicular distance. Is that clear? Now, so this is given it. Okay. What is the first part? We have to calculate the resultant moment of two forces about point A. Okay. So in case 1, you have to find resultant moment about point A. a resultant moment about point A. Now, what this means is, for the first case, what is the pivot? A. A is the pivot now. Okay. So what is the resultant moment at A? So T about A, tau about A is equal to, what is the first force? F A into 0. What is the perpendicular distance of this force from? There is no perpendicular distance, right? So F A is on itself, so 0 plus F T into, what is the distance of FT? 0.5 meter. Is it clear to everybody? FP is, this is the line of action of force from point A, it is 0.5 meter. So this is the net torque at A. Okay. So what is FA? So this is 0, 10 into 0 plus 10 into 0.5. This is equal to 5 Newton meter. And what is the sense of rotation? Clockwise. Okay, everybody understood? Right, let's calculate. This will be what? Now in this case, this will be 0.5 and this will be 0. Okay, so this will be 10 into 0.5.
Yes.
So, 10 into 0. Okay. So you may want to write it this way. Right. So this will be equal to 5. Again, it is 5 Newton meter. Right. So the sense of rotation is again clockwise. Or so you have to find out the resultant moment of O. So in this case, it will be FA to 0.25, FB to 0.25. Because O is equidistant from both the forces. Okay. So again, this is 10 into. Well, also you can write one extra step in terms of forces. So this is 2.5 plus 2.5, 5 Newton meter.
Clockwise.
Both will add up.
Clockwise.
So it is clockwise. If not clockwise, then what it will be? Or minus 5 Newton meter, right? Everywhere. Or so you have to, like, if it is not asked to write in terms of sign, you can just leave it here. Everybody clear on this? Can you do question 7? A steering wheel of diameter 0.5 meter is rotated anti-clockwise. So, anybody would like to try on board? So do it in your notebook. It's a basic question. Yes. Question number, the next question. What is it? Just read it for me. Yeah, the same one, same one. Do that in your notebook. I'll come and have a look.
The currency.
It is given in the question. Okay, so these kind of things can happen. Like your textbook has not been created like that follows. But there is no rule like that. Both persons are writing of which? Yes. Right. So, yeah, so if you have written, if your answer is 3 Newton meter anti-clockwise, it is correct. Yes. All of you, you're getting 3 Newton meter anti-clockwise, and it's all right. Is there anybody who has not understood this concept? We are just applying the formula for moment of couple, which is
Either force it.
yes, either force into perpendicular distance between the forces. Very good. So we will now do the next question. Take the next question. So read the question. The uniform meter rule pivoted at its midpoint. A weight of 50 gram force is suspended at one end of it. Where should a weight of 100 gram force be suspended to keep the rule horizontal? So what does it mean? If it is horizontal, then it is equilibrium. Yes. Okay. So you have to apply which formula? Question number 8. You have a meter rule. So if it is a meter rule, the 0 will be here, 50 will be here, and 100 will be. It is. So it is devoted here. So make a habit of drawing a diagram for the given question. Then the scope of mistake will be minimized. Okay. So draw the schematic diagram for every question. So at one end of it, let us say it is 900 here. You can suspend anywhere, either left side or right side. What is given is 50 gram forces. So if it is gram force, it is mass or weight?
It is.
Okay. So keep it in this unit only, right? Then what is on this? Where should a weight of 100 gram force be suspended to keep the rule horizontal? So we don't know. So let's say we are suspending it somewhere here. Okay. Let's say this is your 100 gram. Again, it is coming down like this. Imagine this distance is x. Okay. So for the meter scale, the horizontal that is in equilibrium. Horizontal means equilibrium. Anti-clockwise moment will be equal to clockwise. Okay, so this is how you have to write. What is anti-clockwise moment? This is 50 gram force. 50. This must be equal to 100 gram force into X. It is centimeter, right? So this gives you X equal to 25. So this means what? 100 gram force have to be
On the 25 centimeters from the
other side of the pivot. Okay. So you can say like, you know, okay, that's sufficient. Okay. So it will be at 75. Answer is that is 25 centimeter. Other side of the okay. So do next two questions also, and then we will move on to the next unit. Okay. Or else, if you have any questions of your choice, I will be happy to do that. 18. Okay. So before 18, let's do 9 and 10 as well. Okay. And I'll explain it. Can I erase that? Now I will not be writing the full description. We'll straight away go to calculation part. Okay. Now that you know. 9. So everybody try 9. I think that is that 78 seconds. So 9 ranges your pivot. Can be which side the weight has to be suspended on the smaller side, right? Because this is a bigger distribution of scale, so weight has to be suspended here. Then you can have it on the right side. Okay, so common sense. So let's say yes, because this is the bigger scale. So अगर यहाँ पे weight नहीं करेंगे तो it will turn anti-clockwise. But to balance it, the weight has to be suspended here. So what is it? So you have to draw the correct diagram, okay?
So we have to suspend the diagram.
हाँ, तो एक यहाँ पे आएगा, आंसर पे आएगा. Correct. This is how much is the weight? 20 gram force. Okay, it's 20 gram. Then you have to find. What do you have to find? So weight
of the meter.
So draw the diagram. Diagram to one here. This is part one.
Yes.
Okay. What is the weight of the? So where is the weight of the lactic at midpoint, right? So this is 50. Weight of the scale W gram force will be at 50. Is everybody with me?
Yes, sir.
Okay. Because the entire weight of the scale will be at its midpoint.
Yes.
What is midpoint? CT of the scale, CT, center of gravity. So everybody understood why this, why W at 50?
Yes.
Because of the concept of CG. CG of the scale is at 50. That's it. So what we have to find out? The weight of the, so 50 minus 58 minus 50 is 8. So by principle of moments, what is it? W into 8. So I say 58 minus 50 is equal to
28 to 28 minus 50.
yes. 100 minus 58.
Yes.
ठीक है चलो कितना हुआ तो 8 equal to how much is it 42 20 into 42 right so W is equal to 28 into 40 over 8 divided by 8. So, yes. क्या करना है इसको? This is 105 into 21, right? Ten is also similar, right? With 10 also you can do. Just the marking is done differently, so I think you can figure out. Shall we go directly to question 18? Unless anybody has question anywhere else. Question number 16. So question number 16. Any questions? Just let me know. Question 16. Any other question? Question 18.
Sir,
Yeah.
can you do question number 11?
Question 11. Okay. Any other questions? Okay, so we'll do question 11. Everybody try question 11. So the diagram is given already. Draw the diagram first. What is it? 10. So marking is done below. At 10 you have 40 gram force. So 40 gram force is hitting. So now the weights are not okay. Let's have one conversation. with me only. So 40-gram force is loaded at mark 10. Now it is not hanging. Okay, it is kept on top. And 20-gram force is at mark 90. Yes, sir. So this is 90. This is a scale. Where this is 90. What is the rate here? 20 grams. Okay. Now what is our situation is? Is the meter rule in equilibrium? That's the first question. Equilibrium. So for equilibrium, anti-clockwise. So for equilibrium, right? For equilibrium, clockwise moment should be equal to minus equal to anti-clockwise. So let's check first. What is clockwise moment? 40. So 50 minus 10. So is equal to how much? 1600 gram force centimeter. This is anti-clockwise. Oh, sorry, clockwise. It's already written clockwise. Right? Clockwise. Wait, this is only clockwise. This is the condition. Clockwise. Since clockwise. No, this is anti-clockwise. Anti-clockwise. Is this and clockwise movement is how much? 20 GF into 90 minus 2. How much? 800. This is 800. So answer is no. No. Clockwise moment is not equal to anti-clockwise. तुम लोग ऐसे मत लिखना, पूरा लिखना, ठीक है? समझ आ गया? Both moments are different, so it is not in equilibrium. Which side will it tilt? Anti-clockwise. Hence it will tilt like this. Yes. Okay. Okay. What is the next part of the question? How can the rule be brought in equilibrium by using additional weight of 40 grams per second? So since it will tilt like this, so we have to put moment on the other side. Yes. Let's say I put some X gram force here. Yes. Why centimeter लेंगे उसमें क्या है?
But the graph is given for the GF.
That is given. अच्छा अच्छा. ठीक है. X ले लो और इसको लिखो 40. ठीक है. और क्या होगा? कौन से साइड में जा रहा है ये? क्लॉकवाइज. So और ये भी क्लॉकवाइज बनाना है. हाँ. ठीक है. तो दो क्लॉकवाइज है और एक एंटी क्लॉकवाइज है ना. क्लॉकवाइज पहले लिखते हैं 40 into x. plus
20 to 40.
Into 40 centimeter. This is equal to 40 into 40. Yeah, that's it. So 40 into something कैसे चला जाएगा? What do we have? X equal to 40 minus 20. How much here? 20. 20 centimeter.
Yes. So like 90K,
So
90,
so
70 by
what should be about 70?
Yes.
Yeah, that is therefore 40 gram force has to be at 70 centimeter bar. To bring the meter scale in, bring the meter scale. So everybody, so have you understood? Kaushal? Kaushal understood how we did? Okay, excellent. Okay. Anybody needs any explanation in this? Okay. Now, what did you not do? Which step you did? So the second part of the question is where this additional 40 gram force has to be kept so that the scale which was like going like this because there was a net anti-clockwise movement. Anti-clockwise movement was greater, right? This is 1600, whereas this was 100 only. So anti-clockwise movement is greater, so it will move like this. Okay? So where this has to be kept so that the rod is brought back to horizontal position. Obviously, since the rod is turning like this, so I have to put a clockwise moment, additional clockwise moment. So I'll load the weight here, but I don't know what position, so X position. Okay. So sum of all the clockwise moments, so it is equal to sum of all the anti-clockwise. Anti-clock is only one component because only one weight. So here, and the weight of the scale is not adding to any moment because it is in the midpoint. Okay, weight is in the midpoint, so it is not producing any turning effect. Only turning effect is these two. So I have gathered all the. This is what clockwise movement. And this is my anti-clockwise movement. Why this? Why principle of moment? So at equilibrium, so I said I'm not going to write the description. So this is the equilibrium condition. What is the condition? Left side is clockwise moment. So due to two forces, two weights. Weight is force, right? And then this distance I have to calculate. This is given 90 is 40 centimeter away. What is 90? 40 centimeter away from 50. So 90 minus 50 is 40. What about this? This you already know. This is at 10. So 50 minus 10 is 40. Okay? So you might have got confused because I've written the units also. So because of that. But anyway, it's okay. So where you don't write the unit? With the unknown quantity. The unit of the unknown quantity is after calculation you will get it. Don't mention the unit of unknown quantity. Then you can cancel on all the units also. So gram force, these two will get cancelled with this one. They will add up, right?
Yes.
Okay. So like that, what will remain is only centimeter. Okay. Only centimeter will remain. Right? Because this thing will go there with the centimeter. Centimeter minus centimeter remains centimeter. Dada. Yeah, I have told you in the last class, stop acting secretary. If he has doubt, he will ask me.
गुलाब सर I disturb
Don't disturb.
इतना sure की जो
अच्छा, ठीक है, दिखाई नहीं दे रहा क्या? तुम्हें दिखाई नहीं दे रहा? Are you not able to see what's going on the board? Please do not disturb the class. Okay? Or else I will disturb you. All right. Anybody has any doubt? Still? Is it clear?
Yes.
Can we proceed?
Yes.
Okay. So the last question, which is 18. 16 also? What are 16? So we did just now is 11. Can I erase it? Please answer this question, question 16. So first draw the diagram. Everybody draw the diagram of this question. So what is given in the question? Where is the meter rule balanced?
Sir, 25 centimeter.
Meter rule is balanced at the mark 70 centimeters.
Sir, that is half meter. That is hold to guide.
Which is question 16? Read the question.
Half meter. I think that is. Balance at 29.
Only the question. I don't have a to make it. Just return your book. So this question is not in the old book. Let me draw this. So if it is a half meter, so what will be the marks? 0 to 50. Okay. Where is it balanced? It is balanced at 29 centimeters. So it will be somewhere here. It is balanced at 29. When a mass of 20 grams is hung from its one end, so where should it be? And here. This is a similar question. What we have done. Okay. So how much is this mass? 20 grams. A 20 gram mass will produce 20 gram force. Okay. Draw the diagram of the arrangement. So this is the diagram. So at 25, will be the weight. This is the CG, right? So weight, ground force will act at 25. Yes. What is this W? Weight of the scale. Okay. Now, so this is part A. The diagram is done. Find the mass of half meter rule. So now by principle of moment, what it will be? W into
29 minus 25.
yes, 99 minus 25. This must be equal to 20 into
21 minus.
okay. 30 होता तो 20 होता, but it is 1 less than 30. 21. So therefore, W is equal to 20 into 21 divided by 4 gram force.
105 gram.
This is 5. 105 grams. Now, so this is what is the weight of the scale. Okay. Then, in which direction would the balancing point shift if 20 gram mass is shifted inside? So, right now this is the equilibrium. Yes. Right now it is in equilibrium. Okay. Okay, now he is still writing. Whose book? So the last part. Last part is what will happen in this weight is shifted in this side. The equilibrium will be disturbed. So this side of the moment will reduce. What moment this was producing? Clockwise. So anti-clockwise moment will increase. So the scale will undergo anti-clockwise moment. Okay, so scale will turn anti-clockwise. Is that the answer? What is the answer?
was pretty much inversion on my. What was the question? In which direction would the balance point shift?
Anti-clockwise direction. The balancing point shift. Okay. Okay. So where should be the balancing point? In the same direction. Towards 25. Because if you move it towards pivot, right, the scale would begin to turn anti-clockwise. So we want to increase the clockwise movement. So this has to be shifted towards 25. Okay. That's okay. It's a logical explanation. Weight and pivot has to be shifted together. Okay. Any other questions? 18. What is 18th question? Is it same? Yeah, same. Can I erase this one? Will force you to come here or you came yourself? You came yourself. Question 8. What do you have? You have a scale, right? Which is now supported at both its ends. Till now we have seen only pivot between like somewhere near the midpoint, right? But now what has happened? It is supported at both the ends, right? So now where is the weight acting? Weight is acting in the middle. Now, is there any turning happening? No. So therefore, there must be some reaction forces.
Yes.
R1 and R2, right? That must be taking place over here. Okay. So now, what is the question? A uniform bar of length L meter. So this is like, this must be L by 2. This is L by 2. Right. A uniform bar of length L meter is supported at its end and loaded by weight W kgf at its middle. In equilibrium, find the reactions R1 and R2 at its end. Right? Now you have to like understand this way. What are the net upward force? R1 plus R2. And what is the net downward force? Now this is static equilibrium. So R1 plus R2 must be equal to W.
Yes, sir, W.
Okay. So net, so in static equilibrium or in equilibrium. Right. Weight and reaction. Textbook line on the table. That's it. So therefore, W is equal to R1 plus this is equated 1.
Yes.
Also, there is no rotation.
Yes.
So principle of moment also will apply.
Yes.
Also, by principle of moment, so yes, these two forces are now you have to choose a pivot, right? So if you choose O as the pivot, okay, midpoint, then W will not have any rotational effect, right? By and at O. What do we get? This is anti-clockwise movement, and this will be clockwise movement reaction, right? So we have clockwise R1 into L by W is equal to R2. So this gives us R1 is equal to R2. So this is equation 1 and this is equation 2. What do we get from 1 and 2? Therefore, 1 and 2. What do we get? W is equal to 2R1 or W is equal to 2R2. Okay. This means R1 is equal to R1 is equal to R2 is equal to W. Both are same.
Yes.
Is also. So all the cases, all the numericals were of static equilibrium only.
Yes.
Right? But only for this question, you had to use this formula as well because there are two variables. That's why. Okay, two variables, R1 or R2. So that is why you have to use this. All right. So we have 10 minutes, and we'll start with next unit. Next unit. I did that. No. Did I explain all this? I think unit A and unit B is over. Let's begin with unit C. Okay. What is yes? What is the silence, everyone? Yes. What is the when a body moves in a circular path. Yes, correct. So a body moving in a circular path with a constant speed. And it is spread the undergoing. You see it. Okay, this is the condition. Now, again, the easy example to understand this is a stone tied to a string. Let us say there is a stone which is tied to a string and it is rotated like this, the horizontal plane. Okay? So what will you feel at your finger? Like how its direction is changing? Sir, where is its direction? Let's say when the stone is being rotated like this and the string breaks, then listen, when the string breaks, does it continue in circular path or it goes straight? So which direction will it go when the string breaks? Upward direction. So it should go upward direction. Now imagine this is a plane of the board. Okay, you're seeing it like this. If it was in your notebook, then it is going north. Okay, so direction is north, south, east, west. So it's the plane of your notebook, and if it is rotating like this, right, then it would have gone north. Okay. Now, but is it so? Like, what about this? If the stone was here, where would it go? Northwest. So earlier the direction was this. Now the direction is. Now, what have you learned? Effects of forces.
Direction is continuously changing.
Direction is changing. That means some force must be changing the direction. The direction of the object is changing. That means there must be some force acting on the object during the circular motion. So if force is acting, that means it is an accelerated motion. So the speed is constant. But what is not constant? Velocity. Because UCM is accelerated motion. So force is acting. So therefore velocity is. Why is velocity not constant? Because its direction is changing all the time. Magnitude of velocity is same, but velocity is changing due to the change of direction at every point. Right? So where is that force acting? Towards the center. Okay, because at this point also, every point the force is shifting. I mean the direction is changing. Its force is acting at every point. Where? Towards the center. Only then force is acting all the times towards the center. Only then the direction will change. Otherwise, it will not change. And it will always keep. So this direction is along the tangent. Okay. So what is the direction of velocity at any point during the UCM, it is along the tangent. Okay? So velocity direction along the tangent and force direction along the center. Since the force is acting towards the center, it is called centripetal force. Okay? So this is the definition of UCM. In UCM, body experiences centripetal force. Okay. Words. Center of circular path. It is a accelerated. Yes. Looking at the accelerated portion since velocity, we are talking about what? About this object with respect to the object. Everything is with respect to this object. Who is what is in museum? This object, stone, the one which is moving in the circular path. Okay. Which agency is responsible for it to move in the circular path? Okay. So when the centripetal force will cease to exist, when the spring is broken. Okay. So when the spring is broken, then it will proceed towards its last direction. Yes. This is the tangent. Yeah. So this is the funda of a body undergoing circular motion. Now there is a concept of centrifugal force also, right? That I think we'll take in the next class because it will take some time to explain. So is the concept of using understood?
Yes, sir.
Read it and come next time. Wait. That's clear. So nobody leaves the class till I leave, okay? That's the simple rule. And I will not leave till the bell rings. That's another one. 1 minute more. Okay. 1 minute more. Okay. So any last minute questions before we ठीक है What is the vortex? Okay, anybody sit down this one small American. What is vortex? So this is this will X by 3, this is X by 3, this is X by 3. What is so much? It is wanted to be fast. Yes. That also. Always late.